Happy Thursday, everybody. Hope your week is going well. We are through our factoring unit and through our mid unit checkpoint. Hopefully, everybody got done with those pages in their workbooks yesterday. We will be looking at those Friday when I get back. Tomorrow, when I get back, we'll be going through those questions and checking some answers against one another. So hopefully you left them in your notebooks. You didn't tear them out. You left them in there. Even if you tore them out, you kept them, you still be fine. We're going to go ahead and finish them and then discuss them tomorrow on Friday. So today we're going into our beginning part of our unit. We're going to talk about, of our second half of our unit, we're going to be talking about adding expressions. Now, this is kind of an interesting unit because we are talking about adding expressions. But if you remember about what we said about the added property of, the commutative property of addition, well, when you add expressions and you add terms and things like that and combine like terms, it shouldn't make any difference the way that we are adding them. So this is kind of a associative property type unit as it relates to adding expressions. We'll talk about the subtraction of expressions next Monday, probably, before we finish out on our unit. But we're starting in today just again on adding expressions. Okay, when we have some type of expression, we have a secondary type of expression that share like terms, and how can we add those together to get some types of solutions. So again, hopefully you have your notebooks out. If you don't, if you're still having, if you're looking around right now and a lot of people don't have notebooks out, you can go ahead and pause the video and make sure everyone has their notebooks out. At this point, you can update your table of contents, and I'm going to go ahead and open my table of contents all the way up. You should have our problems section from Tuesday. Notice I skipped a page because of my, I assume the problems take you a couple pages here. We have our lesson 4.6 today. This is talking about, again, adding expressions. You have today's date, which is February 1st. Happy February, everybody, the shortest month. Leap year, so we have 29 days this month, so kind of an interesting little change there. So again, leave these blank. Depending on how many problems you get finished with, I'll check in with you guys tomorrow on that, and we'll divvy out some stamps for those days as well. But you want to go ahead and update your table of contents to look like this guy. We're going to have one or two more below here. We're going to have problems 4.6. We're going to have lesson 4.7 and problems 4.7, and then we're going to start adding these up and start getting in some points for you guys for Unit 4 for your daily grade. So again, updating that table of contents really put you in a position to get some stamps and put your totals in tomorrow when I get in and we catch up on everything. Okay. So again, we're talking about adding expressions. Okay, so let's look at some of the examples that they're gonna go ahead and give us here. Okay, let's look at our first example. Okay. Our main idea is saying how can properties of operations be used to add linear expressions. So again, properties of operations. These are the things we've been talking about: commutative property, distributive property, things like that. You're going to see a lot of the additive inverse property, the 2-mark method. You're going to see a lot of the commutative property used today. And you're going to see a lot of the stuff we did in unit number 1, where we add and subtract positive and negative numbers today. Okay, so let's look at the example that they're giving us. Okay, they're saying that they have these 2 health clubs that are being signed up for. Okay, we can see the initial fee is your constant, and your monthly fee is how much you're paying per month. Okay, so what they're asking you basically here is, let me zoom out a little bit so you guys can see what's happening. They're going to give you a diagram, but I don't love the diagram. What I'm going to do instead is I'm going to write a expression for each of these 2 situations. Okay, we have a $50 per month fee. Okay, $50 times every month, and we have an $80 initiation fee, right? Our joining fee. So you could say that the cost of the health club right here is going to cost you 50M plus 80, where M is the number of months. So if you are in the club for 10 months, $50 times 10 would be 500, plus that initial 80, you'd pay $580 for this club. Okay. Similarly, down here in this rock climbers gym, it's costing you $40 a month, plus your initial fee of $65. Okay. So because we have like terms here and here, we can combine these 2 expressions to get one expression. So what they're asking you to do here is they're asking you to take 50M plus 80, and they're adding it to 40M plus 65. Now, again, do these parentheses matter at all when we have all addition pieces in here? No, absolutely not, especially when we have variables here that are being added or subtracted, that are being added, but we don't know what they are. So in a scenario like this, as long as I have all addition, it doesn't make a lot of difference if we have expressions or we have terms and what order they're in, okay? So we can kind of just combine like terms. Okay, how much are we paying per month? Well, we're paying $90 per month, right? 50 here and 40 here. And how much did we pay to start up both of these gyms? Well, 80 plus 65. We started, it cost us $145 to start in the gym, okay? So this would be your total cost of these two health clubs. Okay, so again, that's what I want you guys to wrap your brain around when we're talking about adding expressions. As long as everything is addition, we don't care that it's necessarily expressions. Okay, so it's a simple lesson today, right? We're just looking to make sure we only have addition, okay? And we want to make sure that when we only have addition, we're able to add those numbers together because we have the commutative property of addition that tells us that it doesn't matter what order they're in as long as it's addition. Now, this unit becomes complicated if we didn't have the additive inverse theory, the additive inverse property, the two-mark method, right? If we had to deal with subtraction problems and we had to deal with some numbers like that where we weren't sure if the money was being added or subtracted, we didn't know how to add them or subtract them from the two expressions, then things get a little muddy. But luckily, we do use it. And so as long as we're starting every adding of expressions with the two-mark method and we give ourselves all addition pieces, the parentheses really don't matter, right? That's like the 3 plus 4 plus 5 where 3 and 4 parentheses and 3 plus 4 plus 5 where 4 and 5 are parentheses. It doesn't matter what pieces we're adding together as long as we end up in the same place, right? It's like going this way and this way to a house instead of this way and this way, or it'll be this way and this way to the house, right? It doesn't matter how we get there as long as we use the same directions and we end up in the same place, okay? It's much like that with addition, okay? So let's start with something very basic here, okay? This is number one. They're saying that they deposit 120 apiece in their accounts, okay? And then they each make deposits as shown. And they want to know what expression is being represented. So we can see they both make deposits of $120, and then they each deposit $150. Sophia deposits $150 every month, and Ollie deposits $135 every month, okay? So if we had here, let's jump this guy into paint so we can actually write on it. Okay. So what we have is we have them depositing the 120 and then depositing 150 every month, and then we have Ollie depositing the 120 and depositing 135 every month. Now, do we have all additions here? Yes, yes, and yes. So do the parentheses really matter at all? They do not. Okay, so I'm going to give you a minute or two here. I want you to go through and I want you to work through this problem. I want you to get one expression by adding these two together. You should end up with one M term and one constant term. Okay, so go ahead and pause the video. I want you to work through these and then we'll come back and we will look at it. Okay. Okay, so we're back. And again, we can start looking at some of these pieces of information. The parentheses don't matter. So let's look at our constants, right? We have 120. And what they've done here down below is they've used the commutative property of addition to move them around to their like terms. Okay, 150 a month, 135 a month. You can see they have their constant terms here, 240. And they have their monthly terms here, 285 every month. And this tells you for any given amount of time, how much is going to be in their account. Okay, $240 plus $285 every month. So say after 4 months, we could plug 4 in here, multiply it by 285, add 240, and get a total amount that's in the account. Okay, so that's number one. Okay, let's talk about some more here. Okay, let's talk about this guy. Okay, now we've got a lot here. Let's throw this into Paint so that we can. Oops. Okay. We've got some here where we're starting to have negatives and we're starting to have positives. Okay, and the first thing we notice here, I want you to work through this one. I want you to go ahead, make sure you're doing your 2-mark method here, and then I want you to see if you can simplify this. Notice how many different terms we have. We have a C term, we have a P term, negative P term, and we have some constants. Okay, so your final explanation is going to be something C plus something P plus something. Okay, I'm going to give you 3 or 4 minutes here to work through this guy. Okay, go ahead and pause our video. We're going to give you about 4 minutes here. I want you to work through this guy. Remember, the 2-mark method should be your first step. Okay, see you guys in about 3 or 4 minutes here. All right, welcome back. Let's take this and move it down so we can do a little bit of finagle in here. Okay, we notice again, we have a C term, we have a P term, we have no other C's and P terms. Okay, so these two expressions, we can just keep these. These are 9.74C. That's going to go right into here, 9.74C. Okay, we don't have any other C terms that can be combined. We have no other, and I'm going to cross that out as I go. Okay, and again, 2-mark method here before I forget. We have a P term here. I'm going to cross that out as I go. Negative 5.48 P. Okay. Now we have 2 constants that we need to combine, but we need to notice one is negative and one is positive. So remember from unit 1, when you're adding 2 constants together and one is negative and one is positive, you have to subtract their absolute values and figure out which one has greater absolute value. Well, we see that the negative has more absolute value. So your solution to your constant is going to be negative. Well, how negative? Well, we need to do our subtraction piece here, don't we? Okay, 0, 4, 9, 1, 8.8. 9 minus 5 is 4. 24 minus, we get 64.8. So minus plus negative 64.8. Okay, now if you had, let's see, if you had 436.2 here, you added these two together. Okay, but remember, when one is negative and one is positive, think about, look over on your under your sideboard where your major keys are. Okay, under Fat Drake or DJ Khaled, whatever you guys prefer them. Okay, it talks about remembering when you're adding numbers together. Right? If they're both negative, add them together, keep the negative. If they're both positive, add them together, keep the positive. But if they're the opposites, you have to find the difference in their absolute value, which we did here. Okay, we determined that 250.5 is 64.80 farther from 0 than 165.7 is. And we keep it negative because the 250 value has more absolute value, which means your solution is also negative. Okay, so there's a lot going on here. Okay, I understand that. Okay. Hopefully some of you guys got that one. Hopefully you nailed that one down. Okay, let's look at a few more examples here. Okay, this one is even a little bit more complex. Okay, and I know it feels like we're getting into this complex area where things are getting a little rough, but that's okay. That just means you're being challenged. Okay, again, I'm gonna give you a little bit more time on this one. I'm gonna give you 5 or 6 minutes here to work through this one. Again, your steps. 2-mark method, first up, okay? Once we get there, we need to identify our terms. We have a B term, blank B. Actually, I'm gonna put these lower down so I can leave them here. Blank B plus, we have constant terms. So we're gonna have plus a constant at the end. We have D terms, blank D, and we have constants and D's. Okay, so it's gonna be something B plus something D plus a constant. Okay, so again, first steps, 2-mark method, and then I'm gonna give you 5 or 6 minutes here. I want you to go through and see if you can find a solution that finishes in this format here, okay? Adding or subtracting constants, D's, and B values. Okay, I'm gonna give you about 5 minutes here. Okay, welcome back. Let's work through this. Okay, again, the first step, plus a negative, plus a negative, plus a negative. Now we have all addition signs. Now your brackets, your parentheses, basically don't exist, right? Once we get all addition, we can basically just get rid of our parentheses. And now things look a lot similar to the way we've been working in them, okay? We can look first. We have one B term, so we don't even need to manipulate that. That's going straight in. Negative 14.2b. We can get rid of that, okay? Next, let's do our D terms, okay? We have a positive 676, and we have a negative 3.40, okay, or 3.4. So again, we have one positive and we have one negative. That means we're going to need to take and find the difference in their absolute values. Let's do it above my D value so that we know where we're at here, okay? 6.76, and we're going to subtract 3.40 from it, okay? And we get 633, okay? So this is going to be plus 3.36D. Now again, positive has more absolute value than the negative, so this is a positive value. Okay, I'm going to pick this up a little bit so we don't get it mixed in. Okay, and then I'm going to come back up here and I'm going to go dirt, dirt, and I'm going to get rid of my two that I've just manipulated. Okay, and now we can see we have two constant terms. Oh, and lucky us, one is negative and the other is negative. Okay, so all we have to do now is add these two pieces together and figure out how much total negative. We know we're going to have a negative, right? Because they're both negative. Okay, so we end up with 5, 0, find up my decimals, 1, 6, 1, 1, 1. We end up with 216.02. Okay, or 0.5, excuse me. Okay, so this is your total. Okay, and if we look back at it, it makes sense, right? Our D is bigger, our D value is bigger here than it is over here, so it makes sense that it'd be positive. All of our, we're subtracting a constant, we're subtracting a constant, so we're adding a full negative constant here, okay? Our B value hasn't changed because it's all together, okay? So again, if you're getting, your B's and your D's, if you got the B and the constant right, and the D you got maybe something like 10.16, you got to make sure you're checking your positives and your negatives. Okay, think about losing money and gaining money, right? You're not going to lose $6 and gain $4 and say, hey, I have negative $10, so I have positive $10, right? We got to think about what those negatives and positive values mean, right? They have different values. Okay. All right, one last problem here. I believe I did. Okay, this is our last guy. Okay, so I'm going to go ahead and jump this over into my paint here. And I'm going to say, okay, this is number 4. Let's go ahead and find the sum. Remember, our first step is the 2-mark method so that we can get rid of the parentheses. Okay, we got a lot of negatives, we got a lot of values. Again, we have some T values, we have some S values, we have some constants, in fact, one of each. Okay, so we have something S plus something T, and I curl the T so you don't get it confused with any addition signs. That's why they do it as well. Okay, plus a constant. Okay, and this is another one. There's a lot of negatives, a lot of positives. I'm going to give you 4 or 5 minutes here to work through this guy, and hopefully you can get through some of these and we can get a solution. Okay, take about 4 or 5 minutes here. All right, welcome back. Let's go ahead and start where we would normally start. Okay, our 2-mark method plus a negative, plus a negative. And now, again, because we have all addition signs, we can basically erase our parentheses, right? That's the nice thing about this unit is this is kind of a unit of stuff we've done already in Unit 4 plus a refresher for Unit 1, okay? So let's start by rewriting this, and I'm going to use my actual typer because there's a lot going on here. Let's use my, oops, we don't want to underline it. That's going to make things super confusing, okay? So I'm going to rewrite this using the commutative property to put all my like terms together, okay? I'm going to start with my T values, negative 3.5T plus, and down here at the end, right, plus 4.1t, okay, and I'm even going to space these out a little bit, okay, plus email plus negative 4s plus negative 0.3s plus 4.5 plus negative 7.1. Oops, keep that back up here. Okay, so you can see now I've rewrote these. All my t terms are together, all my s terms are together, and all my constants are together. I notice that my s's both negative. I'm just going to slap those two together. 4 plus 0.3 is 4.3. Negative, right? Negative and negative make a negative, okay? These other ones, a little more complex because we are going to have to do some subtracting of differences, okay? So I'm going to make myself a little room here so I can subtract my differences here, okay? I'm going to go ahead and I'm going to write those in, okay? Remember, always start with the one that has more absolute value, 4.1, and subtract the one with the less, which is 3.5. In this instance, we get 0.6. Oops, I got these backwards, didn't I? Good. See, these are little mistakes that we catch, okay? This is going to be your T, and this is going to be your S. Good catch there. If anybody caught that before I caught it, nice work. Remind me when I come back on Friday, extra stamps, okay? Our positive one has more absolute value, so this is a positive value, okay? Over here, same thing. We're taking 7.1 and we're subtracting 4.5, okay? And we're getting 2.6. And again, our negative has more absolute value, so this is a negative value, okay? So we can see our S values, two of them, we add them, keep it negative. Our T values, we add them, our positive has more absolute value, so our solution T has more absolute value. And over here, our negative has more absolute value in our constant, and so our constant has more absolute value. Okay, so hopefully you guys were able to put together some solid problems on that. Okay, if you didn't get to the last problems here, that's fine. If you guys didn't have time to work through them, you're super confused, that's fine as well. We'll be back tomorrow looking through more of these, probably looking at some of your problem sets. Maybe not tomorrow. We might end up just passing on problem sets to work through some of these again and kind of talk about them, okay? We do have time tomorrow to catch up on our stamps, so don't freak out about it, okay? Before I go, I do want to say a special thank you to my special guest here as I'm working through my lesson, Samson. Sam, come here, babe. Come here. You guys aren't here, but we got Mr. Doggo in the house. Hi. Come here. Come here. Oh, he's a good boy. He doesn't know what I'm asking him to do. But hopefully everything is going well with you guys. Hopefully Thursday you kind of understand the basic idea of this. Again, it's just really driving home the importance of the 2-mark method, right? Getting rid of that subtraction to get you into an area where we can do bigger things, combining of expressions and adding and subtracting expressions without having to do these overarching things, okay? The value of that additive inverse theory, the value of the additive inverse property, the value of the 2-mark method. He's over here now. He wants some attention now. Come here. Come here. Oh, yes. Hello. Very friendly. So hopefully the rest of your day goes well. We'll see everybody tomorrow. Thank you again to Mr. Nickerson for being here. He's glad to have him here. He loves coming. All the students were very excited to hear that he was coming. Hopefully his week has gone well. Hopefully your week has gone well as well. Hopefully my week has gone well as well. And I will see everybody on Friday.